You are watching something. It goes blurry for about 10 seconds. Then it comes back. And you blamed your Wi-Fi. Your Wi-Fi was fine. Something else made that call. It made it roughly 3 seconds before you noticed it never asked you, and it will do it again in a minute. So who decided? To answer that, you have to know what a video player actually is. And it is not this. Here's the version the docs teach you. A video tag. A poster image. 3 source files, so every browser finds one it can play. And preload set to metadata, which fetches the duration and the format, but not the film. This is not bad code. It is genuinely correct. It ships on real sites, and for years it was the whole answer. It also cannot explain the blur. So let's watch a real one. Same tag, real product, real network. I'm going to open DevTools before I press play. Nothing up my sleeve. Press play. Watch the panel. Nothing happens for a moment. Then the log starts filling, and it does not stop. This is a real session. Real YouTube, real network, filter set to media. I pressed play, and then I did nothing at all for 74 seconds. 89 requests. 55 megabytes. 1 video, still playing. And look closer, because this is the part that surprised me. Not all of those are video. There's video playback over and over, which is the actual film. But there's also QoE, tracking, watch time, heartbeat, log event. Some of those requests aren't sending you the video. They're sending your behavior back. Now the part that should bother you. I'll drag to 2 minutes 30. Watch. A new request. If the video were downloaded, that would be a seek. It isn't. It's a fetch. You never had the video. One more thing about that log, because it matters later. Every media row on YouTube says video playback with a query string as long as your arm. Not a playlist file. Not a .m3u8. YouTube runs its own delivery on top of Dash. Netflix does something else again. Apple ships HLS. Which is why we'll design against the open standard and then look at what the giants actually do. Which breaks 3 things you probably believe. 1. There is no file. There never was a file. There is a list of files and a strategy. 2. The quality menu is a suggestion. No request in that panel says, give me 480p. Not one. The client decides, and the menu just tells it what you'd prefer. 3, and this is the one that matters. The network doesn't decide what you see. The buffer does. One more thing before we build this. One of those requests contains no video at all. Not a single frame. And if it fails, nothing plays, not 1 pixel. See if you spot it before I say it. Because that's what a player actually is. Not a download. A negotiation. And it renegotiates every few seconds for as long as you watch. So, could you build one? That's the interview. Design the video player for a streaming product. Web first. You have 45 minutes. First move, decide what you're not doing. Out loud. I'm not designing the encoding pipeline. I'm not designing the CDN. No recommendations. And no DRM. That's a whole conversation, and I'd rather do it properly later than badly now. That's not dodging. Accepting every feature is how you fail this round. The candidate who scopes is the candidate who's shipped. What's left is small and honest. Play, pause, seek. Adapt to the network. Remember where I was. Captions. And let me override the quality if I want to. 5 things. That's the product. Now the ones that actually decide the design. Time to first frame. Rebuffer ratio. Seek latency. Memory. And they go in that order. That ordering is the answer. An unranked list is a junior answer because every hard call later is a tie between 2 of these, and if you haven't ranked them, you can't break the tie. Rough numbers. 1080p is about 5 megabits a second. So a 6-second segment is roughly 3 3/4 megabytes. Call it 4. How much do you keep ahead of the playhead? Here's the real answer from a real player. hls.js defaults to 30 seconds or 60 megabytes, whichever it hits first. And that pair is the whole story. At 5 megabits, 30 seconds is under 19 megabytes, so time runs out first. Push to 4K, and the size cap bytes long before the time does. One number would have been a lie. It's a pair. And someone always asks the obvious question here. Storage is cheap. Bandwidth is cheap. Why not just buffer the whole film and never stall again? 3 reasons, and they're all interviews in themselves. First, memory. A 2-hour film at 5 megabits is 4.5 gigabytes. There are television sets in the world with less RAM than that, and they are absolutely watching your video. Second, waste. Most people don't finish. Buffering an entire film for someone who leaves after 90 seconds means you paid for the whole thing and delivered a minute and a half. Multiply that by 1 million viewers and you've bought a second data center for no reason. Third, and this is the one people miss. If you commit to the whole film up front, you commit to a quality up front. The network gets better at minute 40 and you can't use it. It gets worse and you can't escape it. A big buffer doesn't just cost memory. It costs you the right to change your mind. Therefore, a window, not a file. 30 seconds or 60 megabytes. Which brings us to the contract. And there isn't a REST endpoint in sight. This is a master playlist, the real one, from Apple's public test stream. Every entry is a rendition, its bandwidth, its resolution, its codecs, and where to find it. 24 entries in this one, which is not 24 qualities. It's 8 video rungs, offered against 3 different audio options, and the client picks one of each. Underneath, a media playlist. Segment durations. Segment URLs. That's it. The server offers a menu. The client orders every few seconds. Freeze that file. Every decision for the rest of this interview is one of those lines wearing a costume. So which protocol? 3 real options. Progressive MP4. Simple and dead on arrival. You can't change quality mid-file, you can't seek before it downloads, and live is impossible. Dash is good and open and general. But Safari plays HLS natively, straight from a source tag. And browser support for the low-level buffer API is uneven in exactly the places you can't afford it. Therefore, HLS is the floor. But package it as CMAF and the same segments serve Dash 2. One encode, both worlds. Spec, done. Now let's find out where it lives. Before I draw a single box, the question a good interviewer asks, why not just the video tag? Because of those 3 things. No midstream quality change. No seek before download. No live. Every box I'm about to add exists to buy back one of them. If a box doesn't, I shouldn't draw it. Start with what the browser already gives you. It's more than people think. Paused. Ended. Current time. Duration. Volume. Muted. And buffered, remember that one. 2 events do most of the work. Loaded metadata, when it learns what the film is. And time update, which fires as it plays. That's the control surface. Everything above it is just a very determined way of feeding it. And this is the part that changes the game. A media source object replaces the file. Inside it, source buffers, and you append bytes to them yourself. In JavaScript. At whatever moment you choose. Audio and video are separate buffers. They're fetched separately, appended separately, and they can be at different points at the same time. Which is exactly as fragile as it sounds. 2 small pieces next. Something to fetch, text playlists first, binary segments after. And something to parse those playlists into a list of things worth fetching. Boring. Necessary. Moving on. Then the interesting one. Something has to decide which rendition to pull next. That's a whole act on its own. I'll come back to it, it's the best thing in this video. Something has to append those segments and evict them when we hit 30 seconds or 60 megabytes. Which sounds like housekeeping. It isn't. This is the component that decides whether you see a spinner. And on top, an orchestrator. It runs a state machine, and it wakes up 10 times a second, forever asking one question. What should I be fetching right now? That's 6 boxes and it feels tidy. Here's the real thing. A production player ships around 15 controllers. ABR, stream. Audio stream. Audio track. Buffer. Cap level. FPS. ID3. Level. Subtitle stream. Subtitle track. Timeline. Gap. Latency. And encrypted media. 15 coordinating components to play a video. And people call this the front end. Let's follow one playback, start to finish. 1. Fetch the master playlist, what qualities exist. 2. Fetch the media playlist for the one we picked. 3. Fetch the init segment. Hold that thought. 4. Fetch the first media segment. 5. Append it to the source buffer. 6. The browser decodes it. 7. Pixels. 8. And this is the loop that never stops. Measure how long that took and decide what to fetch next. Then do it again. And again. Until you close the tab. If this is landing, subscribing genuinely helps. Back to it. So we have a design. On a good network, it's beautiful. And there's one box left with a question mark on it. The thing that picks the next quality. Let's do the obvious thing. Time each segment. Divide bytes by seconds. Average the last few. Pick the best rendition that fits. That's 4 lines of code. It is the answer almost everyone gives. And on paper it's correct. Now let's put it on a real network. Segment 1 arrives fast. The average says 5 megabits. We're on 1080p, good. Segment 2 hits a bad moment. 900 milliseconds. The average drops. We fall to 720. Segment 3 is smaller now, so of course it arrives quickly. The average jumps back up. So we climb to 1080p again, which is bigger, which takes longer, which drags the average down, which drops us to 720. Do you see it? The player is chasing its own tail. Every good measurement it takes is a measurement of a smaller file, so it's not measuring the network, it's measuring its own last decision. Up, down, up, down. And that isn't a rare edge case. That is the default behavior of the obvious solution on an ordinary connection. Here's the part that matters, and it's not the graph. Nobody watching this says the adaptive bitrate controller is oscillating. They say the video keeps going blurry. They say it looks broken. Some of them leave. A design can be technically correct and still feel cheap. So the naive player fails, and it fails for an interesting reason. Not because it measured badly. Because it believed what it measured. Which tells us what the real one has to do. Not measure better. Trust less. First, clear something up, because conflating these two is the classic mistake. The video element has a readiness ladder. 5 values. Have nothing. Have metadata. Have current data. Have future data. Have enough data. That ladder answers one question. Can we show a pixel right now? The player has a completely different machine. 12 states. Idle. Key loading. Frag loading. Waiting retry. Parsing. Parsed. Ended. And so on. That one answers a different question. Is the next chunk coming? They are not the same machine. They disagree constantly, and almost every confusing playback bug lives in the gap between them. And 2 of those 12 states tell you things a diagram never will. There's one called key loading, which means before this player shows you anything, it may have to ask a license server for permission. That's a full network round trip to a completely different service, sitting between you and the first frame. It's why encrypted content starts slower. There's another called waiting for init PTS, presentation timestamp. Remember that audio and video are separate buffers, fetched separately? Something has to decide where 0 is, so the 2 agree. This state is the player standing still, holding a chunk of audio and a chunk of video, refusing to begin until it knows they line up. The audio is out of sync bug you have ever filed lives near that state. And parsing happens somewhere you might not expect. The unpacking runs in a web worker off the main thread. Because doing that work on the thread that draws your interface is how you drop frames while appearing to do nothing at all. Now, that buffered property I told you to remember. Most people picture a bar filling up. It isn't a bar. It's a list. Ordered ranges that never overlap and never touch. Which means your buffer is islands with water between them. And those gaps are why seeking is expensive. Land between 2 islands and there's nothing to play, even though the buffer is technically full. Which brings us back to the box we broke. We know what doesn't work. One average, trusted completely. So, what does a real player do instead? A real player runs 2 averages at once. One fast with a 3-second memory. One slow with a 9-second memory. And then, this is the line. It takes the lower of the 2. The comment in the source says it plainly. Adapt down quickly. Adapt up slowly. Think about what that buys. Your connection dies. The fast average collapses. The minimum follows. You drop quality immediately. Your connection recovers. The fast average jumps, but the slow one hasn't forgiven you yet, so the minimum stays low. You climb back carefully. The player is pessimistic on purpose. And one more detail nobody mentions. Each sample is weighted by how long the download took. So a slow download doesn't just lower the average, it dominates it. Bad news is louder than good news by construction. And that's only half of it. Before it commits, the player discounts its own estimate. To stay where you are, it trusts 95% of what it measured. To move up a rung, it trusts 70. Which means, in practice, You need about 1.5 times a quality's bitrate to climb into it, but only about 1 nanobit to stay. Getting worse is easy. Getting better has to be earned. And that is the fix for the tail chasing we watched earlier. The fast average still spikes when a small segment lands quickly. But the slow one hasn't forgotten the bad minute yet. The minimum stays down, and the 70% tax means one lucky segment can't buy a promotion. Same measurements. No oscillation. Now, that request I told you to watch for. It's the init segment. And it contains no video whatsoever. It's the instructions. Which codec, which dimensions, how the bytes are laid out. Without it, every segment that follows is a few megabytes of noise the decoder cannot interpret. Hundreds of requests carrying the film. And the one that makes it a film carries none of it. One more honesty problem. Before the first segment lands, there is no data to average. So the player opens with a guess, 500 kilobits. Every video you have ever watched started with a number somebody hard-coded. And there is a second estimator, which almost nobody talks about. Bandwidth isn't the only thing that can be slow. A server can be quick to send and slow to answer. So the player separately tracks time to first byte, the gap between asking and hearing anything back. That one is weighted differently on a curve, so that unusually long waits count for less rather than dominating. Why bother? Because the two failures need opposite responses. Low bandwidth means ask for something smaller. High latency means the size of what you ask for barely matters, and asking earlier does. One estimator for how fat the pipe is, another for how far away it is. And when the guess is wrong, it does something ruthless. If fewer than 2 segments are buffered, and the one in flight won't arrive before you run dry, and a smaller one would, it kills the download. Mid-transfer. Throws the bytes away and asks for a worse version. Wasting work to avoid a spinner. Correct and slightly brutal. This is also why seeking is harder than it looks. Land in an unbuffered region, and the player may have to evict what it holds before it can append what you asked for. And whether 2 islands count as one is a tolerance setting, a tenth of a second, deciding whether you stall. Which reframes something you see every day. That spinner isn't the video loading. It's the buffer controller telling you it lost a race. 5 ways this breaks. First, the network drops mid-segment. The estimate falls, the player drops a rung, and the next request is smaller. But you don't see it yet because 30 seconds of high quality is already buffered, and that plays first. That's why quality always seems to change a few seconds after your Wi-Fi did. Second, 1 segment 404s. Retry it. Still failing and we're not on the lowest rung? Then drop straight to the bottom. Not 1 step down, the floor. Something is wrong and the priority is playing something. Third, and this is my favorite thing in the entire codebase. Sometimes the playhead stops. Not because the buffer is empty. The data is right there, buffered, decoded, ready. So what does an industry standard player do? It nudges it. It moves the current time forward by a tenth of a second to see if that shakes it loose. If that doesn't work, it does it again. And once more. 3 pokes. And if the video still hasn't moved, it gives up and throws an error that reads, playhead still not moving while enough data buffered. Millions of hours of engineering. And the fix is to jiggle the clock and hope. Fourth, memory. Never evict, and you'll take down a smart TV in under an hour. And there's a twist. On modern browsers, the browser can evict your buffer whenever it likes. Memory pressure, hardware limits, its own judgment. It just tells you afterwards. Something you never called can delete your work, and your only job is to cope. Fifth, if you're doing live, you drift behind. And the fix is not what people guess. The player doesn't slow down. It speeds up, a few percent, never below normal, capped at double. And it's switched off by default, because getting it wrong is worse than being late. But the more interesting question is why you were behind in the first place. By default, a live player deliberately sits 3 segments back from the newest thing available. Not 2. Not 0. 3. Why? Because the newest segment is the one most likely to not exist yet, or to arrive late, or to be the one the packager is still writing. Sitting at the very edge means every hiccup upstream becomes a stall on your screen. So the player trades seconds for stability. And that is the entire reason your stream is behind the television, and why the neighbors cheer before you do. That delay isn't lag. Somebody chose it. Which is also the thing to say out loud in an interview. Every latency number in a live system is a decision, and if you can't name who made it and why, you haven't finished the design. And none of this is hypothetical. This is the issue tracker of the most installed video player on the web. Issue 4823. Buffer stalled error after segments missing audio. Which is exactly the thing we just described. Audio and video live in separate buffers. One of them has a hole. The playhead reaches it and stops, with plenty of video sitting right there. It was opened in 2022. It is still open.
And that is the well-understood part of the problem.
So, what would you actually pick? hls.js if you're serving HLS and want the shortest path. Shaka if you need dash and serious DRM. Dash.js if you're living in the spec. Video.js if the UI matters more than the transport. Native if you're only on Apple and you enjoy sleeping. One footnote. The comment at the top of that clever estimator says, heavily inspired from Shaka Player. The two biggest players share their maths. Nobody's hiding it. Which leaves one last thing. Go back to the progress bar. The most boring object on the internet. The duration on it arrived as metadata, and on some phones it arrives wrong, or late, or not at all, so the bar you're looking at was often drawn before anyone knew how long the video was. The quality you're watching is a bet, placed a few seconds ago, on a connection that has since changed. The buffer behind it is islands, not a bar. And the spinner is an apology. None of that is broken. That is the product. A video player is a machine for taking a stack of guesses and making them feel like a certainty. You have never watched a video. You've watched a negotiation that went well. Next time, the follow-up round, seeking into nothing, DRM, and how you'd prove any of this in production. The full breakdown is in the repo, linked below. This is beyond code karma. One last look at the whole machine. At the top, the video element, the thing you actually wrote. Under it, MediaSource Extensions, and the source buffers you feed by hand. Feeding those, the buffer controller, holding 30 seconds or 60 megabytes, whichever comes first. Deciding what goes in, the ABR controller, with its two averages, its minimum, and its 70% tax on optimism. Around them, the loader and the parser, turning playlists into work. Orchestrating all of it, the stream controller, waking 10 times a second to ask what's next. And underneath everything, the gap controller, watching the playhead, ready to nudge. 15 components. One video tag. That's the last mile.